So we are given that a, b, and c are distinct natural numbers less than 20, and we're trying to find the maximum value of absolute value of a minus b plus absolute value of b minus c minus the absolute value of c minus a. And so absolute value means the distance between two numbers on a number line. So right away, we notice that these two values here, a minus b and b minus c, are added, and this c minus a is being subtracted. So to maximize this total distance, we want to have these added distances up here be as large as possible, and then we want that c minus a to be as small as possible. So what numbers affect both of these positive distances? And that one would be the number b. So in this case, both a minus b and b minus c absolute values grow when b moves farther away from the other two numbers. So the strategy is to put b as far away as possible from a and c and keep a and c next to each other. So let's say b is 19. B is 19. Now let's think about a and c. In order to make this value here as big as possible, we want a to be as small as possible. We said that we want distinct natural numbers, so the smallest possible a can be equal to 1. And now, at the same time, if we want this piece to be as small as possible, we want something minus a to be really small. So the other distinct natural number available to us is 2. So if we solve for this equation up here, we get a minus b is negative 18. Absolute value of that is going to be 18 plus b minus c is 17. Yep, 17. And then minus the absolute value of c minus a, which is 1. So minus 1. That would be, this is 35 minus 1, that's equal to 34. So 34 captures the best possible scenario. So takeaway is that when the expression is adding to the total value, you want to make this as large as possible. And when subtracting, you want to make it as small as possible.